Okay, hello everyone. Welcome to the webinar. While people are joining, does anyone have any questions? Any questions? I can quickly answer. I hope not too many, but I can answer a few questions. Okay, I'm going to agree with the last question. Well, watch the webinars. Oh, what is the last question? Which one are you talking about? COMPOS. Let's have a look. Physics. Last question. Oh yes. Well, it's a tough question. So watch the webinars. I have 2 webinars where I discuss that question. So go to last year's webinars. Concerning the last question. Does COMPOS help with entrance exam later in the year, in year 13? Well, yes, of course, because if you do COMPOS, you'll be better at physics. So you will be able to do all sorts of questions, all sorts of hard questions. So we do questions which are PAT level and even harder than PAT. So some of our questions are harder than PAT. You wouldn't have, like the question you're mentioning, the problem 13 from the, you wouldn't have this in PAT. This is not a PAT question. It's way more advanced. So you are, it's, yeah, so it does help, of course. And it does help you. We want you to become a very good physicist. We want you to become very good physicists. Yes, and that's why we give you all these sorts of questions, and also a tutor which will help you to plow through these questions. What happens if we don't meet the deadline for the assignment submissions? Well, if you don't meet the first assignment, then you probably won't be able to get in, because unfortunately we are quite tight. If you get in, but then you miss an assignment, well, you can miss maybe 1 or 2, but if you miss more than that, we'll offer your place to somebody else. Is there a difference between a percentage increase and a percentage point increase? Yes, a percent. Let's say I pay 20% tax. Now, my tax has increased by 50%. How much am I paying now? So I pay 20% tax. My tax has increased by 50%. No, it's definitely not 40. 30%. Yes, Tom, thank you. Now, if I say my tax has increased by 50 percentage points, how much am I paying now? 70. Yes, so that's it. Do you see the difference? If I say my tax increased by 50%, that means it went from 20 to 30. If it increased by 50 percentage points, it went from 20 to 70. Okay, so something is a nightmare. If you can have a nightmare like at 70% tax, it's just like, and in the direction of a vector and gave an angle, would it be implied? Yeah, if you give an angle, you don't have to, it doesn't have to be in a angle to a specific direction. As long as you quote it, like you can say 30 degrees to the vertical, or you can say 60 degrees to the horizontal, or you can say 120 degrees to the other horizontal, right? So as long as you clearly indicate what are you referencing to, then it's that. You can use bearing. You can say bearing 270, or you can say 90 degrees left, or 90 degrees west of north. So another. So as long as it's clear, we don't penalize for alternative ways of mentioning angles. Right. Okay. Perfect. Right. So let's go with some questions. The questions today are slightly more mathematical than physical, but we will have 2 physics questions at the end, so purely physics questions, or maybe we'll yeah. So I'll share my screen and hope share my screen. Okay, you should be seeing my screen. If you don't, something's wrong. Let me know. Right. So some of the questions are very similar to what you're doing in the assignment, and I might be repeating myself because I think I've done some of these questions. But anyway, vectors a plus b and a minus b are perpendicular. Prove or show that they have the same magnitude. Okay, so let's see what we can do. Well, if they're perpendicular, what does that mean in terms of their product? The dot product is 0, absolutely. So they're perpendicular. That means that A plus B multiplied by A minus B is 0. If we expand this, we go A times A, so it's A times A, that's A squared. Now, I have to mention what A squared means. Well, A squared is simply A times A. But you know that the scalar product, the dot product, is modulus A modulus B multiplied by cosine of the angle between them. What's the cosine? What's the angle between A and A? 0. So what is cosine 0? Is 1. Very good. So it's A times A. So it's a modulus A times modulus A. That is simply, so A times A is simply modulus A squared. So it is important to understand this. Like, it's important to understand that modulus, so A times A is the same as modulus A squared. Or simply, this can be written as A times A is equal to A squared. Because when we write A without a vector, that means the modulus. So A means this. Okay, so sometimes I'll be writing it like this. Just so in physics, when you see F, that actually means modulus F. The same as. And acceleration is the same as the modulus of the acceleration. Okay. I have to say, not every physicist adheres to these strict rules. So just be careful. Sometimes it can mean other things, especially in a school setting. So a squared, and so a minus a times b plus b times a minus b squared. This cancels out. And you have a squared minus b squared equals 0. And that means a squared minus b squared equals 0. And that means that a squared equals b squared. That means modulus of a squared is equal to modulus of b squared. I've shown you why, yeah, because of this rule. And that means that modulus of a has to be equal to modulus of b, because they are both positive. The modulus can't be negative, therefore. So, and that's QED. If adding vectors tell you the resultant, so Anish is asking, if adding vectors tells you the resultant vector, which has the same effect as both of the two original vectors, what is multiplying two vectors? What does multiplying two vectors actually mean? QED, I forgot. QED meaning. It's quod erat demonstrandum, means we have proven which was to be demonstrated. QED. Quod erat demonstrandum. I was trying to remember this. But yes, quod erat demonstrandum. That's something that you write at the end of a mathematical proof. Okay. So whenever you see that, that's what it means. So multiplying two vectors actually mean multiplying two vectors well, it can mean different things. It can mean work done, for example. So meaning of product of vectors. Meaning of a. First, force multiplied by displacement is work done. That's one meaning. Then 2 weeks ago, I was showing if you have A multiplied by B divided by modulus of B is the projection of A onto vector B. So it's a projection of a vector onto another vector. Basically, you have a vector B, and you have a vector A, and this is a projection. So this is the projection of A onto B. So that's the meaning of that. It's the length of the projection. So yeah, that's meaning, but it doesn't have a simple meaning as in adding vectors. Okay, problem 2. In triangle ABC, and you see that we are stepping into the wonderful world of three-dimensional vectors. Three-dimensional vectors, but shouldn't be scared. It's not scary. Well, not very scary. You should be able to imagine that in 3D, right? So in 3D, you have the y-axis goes to the right. That's the standard way of drawing it. The x-axis goes upwards, and the x-axis goes towards you. Now, you could potentially draw it like this, like a dot, like this is the x-axis. That's not very useful because if you move along the x-axis, you can't tell that you're moving along the x-axis. So we draw the x-axis at an angle. We draw the x-axis like this. So this is a three-dimensional picture, yes, where z going up the page, y is going to the right of the page, and x is going towards you, towards your face. No, whatever's in that left corner. So yeah. So 1, 1, 1. So that means 1 on x, 1 on y, and y on z. So you go 1 along the x-axis, y along the y-axis, and y along the z-axis. So point A, which is 1, 1, 1, is here. It's in 3D. I hope you can picture it. B, which is 3, 0, 1. So it's 1, 2, 2, 3, 0, 1. So B is here. So we go 3 along the x and 1 along the z. So that's B, 3, 0, 1. And then we have C, which is 0, 3, 1. 0, 3, 1, 2, 3, 1, C. So we have a triangle which is in three-dimensional space, which looks like this. Okay. Does everyone understand what I've drawn? It's a three-dimensional triangle in 3D. I'm happy to explain if you're confused. All right, so C has coordinates 0, 3, 1. Find the unit vector in the direction of the angle bisector of BAC. BAC. So we have BAC. Okay, and we need the angle bisector of the angle BAC. So basically, we can redraw this. So this is B, B, A, C. And we need the angle bisector like this, such that this angle is equal to this angle. Well, we'll start with finding the vector AB and vector AC. It's always a good start to do this. So vector AB is equal to OB minus OA. And OB is 3, 0, 1 minus OA, which is 1, 1, 1. So this is a position vector of B. This is a position vector of A. So this is O, this is A, and this is B. So vector AB can be written as vector OB minus OA. I hope that makes sense. I hope that makes sense because O is the origin. O is the origin. Unit vector means vector of length 1. So this is going to be 2 minus 1, 0. And vector AC is OC. So the coordinates of B and A from the origin, yes. How do you know the direction of the vector? What do you mean, how do I know the direction of the vector? I'm just saying because it goes from, I'm looking for a vector A, B. If I was looking for vector BA, I would do the opposite way. I want vector which goes from A to B. Now I want a vector going from A to C, so that's OC minus OA, which is 0, 3, 1. Does that answer your question, Hossam? I'm not sure what you meant. Okay, thank you. OA, and that's 1, 1, 1. So that's minus 1, 2, 0. Okay. So we have vector AB and vector AC. And we need to find the bisector. Okay. What we have here is we notice that if we find the modulus, of AB is equal to square root of 2 squared plus 1 squared plus 0 squared, which is square root of 5. And modulus of AC is equal to square root of 1 squared plus 2 squared plus 0 squared, which is also square root of 5. Conveniently. So conveniently, AB is equal to BC in terms of the well, basically it's a isosceles triangle, and that helps us a lot because if it wasn't, we would be in trouble. Now, if we complete this and make it like this, and write a point D, then because AB is equal to AC, that means that ABDC is a rhombus. And because it is a rhombus, it is also a parallelogram, because a rhombus is any rhombus is a parallelogram. Any rhombus is a parallelogram. Where did you get the numbers in the square root? Well, the modulus of a vector, AB, okay, if you have a vector, if you have a vector A, which has coordinates x, y, and z, then the modulus of this vector is square root of x squared plus y squared plus z squared. If it's a two-dimensional vector, like xy, then modulus of b squared is x squared plus y squared. And even for a one-dimensional vector, modulus of c is equal to square root of c squared, which is c. Well, anyways, let's not do this. Just making a point. Karim, does that answer your question? Where did I get the numbers in the square root? Okay. Saida, could you please demonstrate the diagram when origin is used, for instance? Okay. Yes, I think that is an important point. So let's just pause for a second and go through this. Thank you for the question. I was hoping to avoid it, but let's say you have a point. a point A with coordinates 2, 1. And you have a point B with coordinates 1, 7. And you have a point O, which is the origin. The vector drawn from O to A, vector OA, is equal to 2, because it goes 2 to the right and 1 up. Vector OB goes 1 to the right and 7 up. Yeah, so 1, 7, which makes perfect sense. Okay. Now, using the we want to find vector AB. We want to find vector AB. We use the triangle rule. Vector AB can be written as AO plus OB. But AO is also known as minus OA, so which is minus OA plus OB. So in other words, vector AB is equal to OB minus OA. That's it. This is true for any 2 points. True for any points A and B. Okay. Vector OA and OB. Nope. Vector OA and OB are known as the position vectors. Position vectors of A and B. Does that make sense? Saida, does that add to your understanding? Yes. Okay. How would you, Abiola? How would you find the angle? Well, let's get to it. Is any rhombus is a parallelogram. Therefore, AB plus AC, we're using the parallelogram rule. So according to the parallelogram rule, AB plus AC is equal to AD. So using the parallelogram rule. Now, if vector AD, and vector AD is AB plus AC, so it's 2 minus 1, 0, plus minus 1, 2, 0. So that's minus 1, plus 1, sorry. Oh, plus 1, 0. Oh, beautiful. So AD, but AD is the bisector. AD is the bisector, the angle bisector. Because in a rhombus, it splits the angle into 2. We don't need the angle, by the way. We don't need the angle. You could find the angle, but you don't need it because you just found. And now you need the unit vector. So the unit vector is a vector of length 1 in the direction of AD. Let's give it a name. Let's call it U. Is a unit vector. And there's an ingenious way of finding a unit vector. Unit vectors. A unit vector is a vector of length 1. Suppose you have a vector of Suppose you have a vector of length 7. Well, I don't know. Of length. The length of this vector is modulus of A. Imagine you have a vector of length 7. If you divide that vector by 7, you get a vector of length 1. Right? So if you divide, to get a unit vector in the direction of A, you need A divided by modulus of A. Unit vector is, yes, it just tells you the direction. So to find a unit vector, you take the vector and divide it by the length of itself. All right, so to find the unit vector in the direction of AD, so unit vector in the direction of AD is equal to AD, vector AD, divided by the modulus of AD. Or in other words, 1 divided by modulus of AD multiplied by AD. And that's what you do. So the modulus of AD, modulus of AD is equal to the square root of 1 squared plus 1 squared plus 0 squared, which is square root of 2. So it's 1 divided by square root of 2 multiplied by 110, which gives you 1 divided by square root of 2, 1 divided by square root of 2, 0. And that's the answer. What if A is negative? A can't be negative. What do you mean A is negative? Like modulus of A is a positive number, and A is a vector, and vectors can't be positive or negative. Until we tell you that velocity can be negative in physics, right? I know it's horrible, but a vector is an object that cannot be positive or negative. The length of a vector is non-negative. But you can't even compare, like you can't say vector A is greater than vector B, right? Therefore, you cannot say that vector A is greater than the 0 vector. A 0 vector is a vector. So that's an important thing. A vector cannot be positive or negative. What we mean when we say in physics, we say velocity is positive. What do we actually mean when we say that? We mean that if we project the velocity onto the x-axis, it's going to be negative. So for example, we have a vector. This is vector vector A. And this is the projection of that vector. And that is a positive number. Yes, because a projection is only one number. A vector is 2 or more numbers because a vector has 2 components. So it can't be positive or negative. I hope that makes sense. And a projection can be. And when you're doing SUVAT in physics, in A-level physics, you always say, oh, the positive velocity of negative velocity. That simply means the projection of the velocity on the x-axis is positive. The projection of the velocity onto the x-axis is negative. That's what we mean when we say positive or negative velocity. I hope that makes sense. Can a vector have 3? Yes, a vector can have 3 components, or 4, or 5, or more. Okay. For 3 dimensions, yes, we use 3 dimensions, but for example, a vector can be x, y, z, and time. Yeah. For example, the x direction, y direction, z direction, and time. In many applications, you use multidimensional vectors. For example, in economics, you use, for example, the prices of goods. Goods can be expressed as a vector. So 8, 7, blah 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 until 12. Could be in this vector can have any number of dimensions. So yeah. Okay. Is projection on the x-axis the same as x cos theta? Yes, it is. Where theta is the angle between the x-axis and this. All right. So does question 2 make sense? Do you understand question 2 on a scale of 0 to 10, please? Okay. Why did you multiply by AD? Paris. I still don't know how a vector can't be negative. For something to be negative, you need to be able to compare it. Because minus square root of 7 is negative because it is less than 0. Okay. Now a vector A, cannot be bigger than vector B, for example. It does not make any sense. Does not make sense. Not make sense. You can't compare 2 vectors, and you also cannot compare a vector to a scalar. That's even that makes even less sense. So vector A greater than 0, where 0 is a scalar, that doesn't make any sense whatsoever. In the same way, you can't compare vector A to a 0 vector. Also doesn't make any sense. Therefore, if you cannot compare something with 0, that means it can't be positive or negative. Does that clear things up, Harris? Why does comparing vectors not make sense? No, that's fine. That's you're asking very good questions. Well, because a vector has a direction and a magnitude. It has 2 things. And what do you mean when? Well, if you have vector 3, 7, and you have vector 7, 3, are they equal? Well, they're not equal. If they're not equal, then is one of them greater than the other? Can you say that 3, 7 is greater than 7, 3? No, you can't. Can you say the other way? Can you say that 3, 7 is less than 7, 3? Do you get my point? They're modular. Yes, you can say that 3, 7, the modulus of 3, 7 is equal to the modulus of 7, 3. Yes, you can do that. But modulus can't be negative. You can compare the modulus of a vector. Yes, you can compare the directions, but you can't compare the vectors. Very good. That's a very good understanding. When a vector is written as -2, 7, for example, is this in comparison to the origin? And if it is not in comparison with the origin, would the vector be 2, 7? A vector -2, 7 is well, it's a very specific vector, -2, 7. So if you start from the origin, you go -2, 1, 2, 7, 1, 2, 3, 4, 5, 6, 7. This is vector -2, 7. And vector 2, 7, it goes 2 to the right and then 7 up. This is vector 2, 7. They're two different vectors. And they're not bigger or less than each other. You can't compare them. They're not equal to each other, but neither one is greater or smaller. But that would never be negative unless relative to each other. Yes, I mean, you can say that the projection, look, you can say that the projection of this vector onto the x-axis, the projection is this, is +2. And the projection of this the vector onto the x-axis is -2. So you can say that the projection of 2, 7 on the x-axis is positive. Yes, you can say that. You can also say that the projection of this on the x-axis is less than 0. Yes, you can say that. So it's a projection of one vector onto another is. And remember, projection is a scalar product. And a scalar can be positive or negative, right? A scalar can be positive or negative, but a vector cannot. And that's like, I mean, these are very interesting discussions to have on the nature of vectors. Just one more thing. Another definition of a vector. A vector is an ordered set of real numbers. A vector is an ordered set of real numbers. So for example, 3, 7. It's important because 3, 7 is not the same as 7, 3. So it's an ordered set of real numbers. Or vector B, which has 3, 0, 7. It's a vector. Or vector C with 4 components, 3, 0, 7, 9. Yes, you can think of a vector of a 2x1 matrix, absolutely. A vector is a 2x1 matrix, is in a way. So yeah. So a matrix, of course, cannot be positive or negative, and a matrix is a matrix. Okay. Do we need to know the equation for tension in problem 11? Or we're supposed to do it another way? Equation for tension. I'm not sure what you mean by equation for tension. No, it can be clearly solved by looking at the forces acting. You might want to cut the rope into pieces. Okay. That's a big hint. Problem 3. OABC is a parallelogram. Have we finished? Yes, we have finished. Find the ratio of OA to OC and find the equations of the sides of the parallelogram as well as the equation of line AC. So this is just practicing using vectors. So nothing special about this problem. Wouldn't say it's one of my favorite. So OABC. So O is the origin. So that's 0, 0. A, that's 3, 6. And B is 8, 6. Do you notice how I don't, I'm not actually drawing them accurately because that's not important. I'm not using I could use a grid, but it's really not important. OABC, not OABC. Oh, interesting. Just let me check. It's supposed to be OABC. AC is a diagonal. Yes. Okay, I have made a mistake. A, B, 8, 6, C. C is question mark. Isn't it important that A and B are on the same line? Yes, it is. Have a quick question regarding the mass interest. Could you please tell me if the assignment is directly related to Edexcel, or is it more to do with further maths? We are not basing it on any exam board. We're not basing it on Edexcel. It has no relation to the Edexcel math course. The topics are roughly the same. The topics are roughly the same, but the style of questions is different. We don't use A-level questions, pretty much never. We use MAT style questions. We use PAT style questions. So yeah, that's not at Excel. I hope that helps. Look, if you can confidently do COMPOS questions, you will have no problem solving Edexcel questions. Okay, so our questions are harder, hopefully. Okay, so we have OABC. OABC, O is the origin. Find the ratio of OB to AC. Well, that's very straightforward. OB. So OB is the diagonal. So OB is equal to OA plus AB. So OA is 3, 6 plus AB. And we know that AB can be written as OB minus OA. This we know from the previous example. So OB is 8, 6 minus 3, 6, which is 5, 0. Ooh. 5, 0. Interesting. Is it? Oh yeah, it is. Okay, 5, 0. So that's 8, 6. Okay. I think I did something silly, but anyways, yes, OB is 8, 6. It is true. Yes. I wonder why I had to do it this way. Yes, OB is this vector. And you need the modulus of OB. The modulus of OB is square root of 8 squared plus 6 squared. Ooh, and conveniently that is 10. Now we need the modulus of AC. Question mark. Okay, so how do we find AC? Now to find AC, we need to find OC first. And we can write that OC, that OC is equal to AB because they are parallel and they're equal in length because it's a parallelogram. So OC is equal to AB. So, and we know that AB is 5, 0. 5, 0. So OC is equal to 5, 0. And that means that point C is 5, 0. So 5, 0. And that's square root of 5 squared plus 0 squared, which is 5, of course. So AC is 5. So the ratio of OB to AC is 10 to 5, which is 2. That's the answer. Find the equations of the sides of the parallelogram. Well, as well the equation of the line AC. AC. Oh, sorry. Yes, you are correct. I don't need to delete that. That's OC. Thank you. Sorry. Embarrassing. So I need AC. So AC is equal to AB, can be written as AB plus BC. So AB is 5, 0 plus BC, and BC is BC is equal to minus OA. So it's minus 3, minus 6. So it's 2 minus 6. And the modulus of AC is equal to square root of 2 squared plus 6 squared. So that's square root of 40, which is 2 square root of 10. So the ratio OB to AC is equal to 10 divided by 2 square root of 10, which is square root of 10 divided by 2. That's it. That's the solution. Why do we have to find OC? We don't. I just made a mistake. We need the vector OC to find. Oh, we don't actually need the vector OC, do we? Yeah, we don't. Absolutely. Sorry. Just my brain. OC. Let's delete the stuff that we don't need. Yeah, that's fine. How is OB 10? 8 plus 6. 8 squared, 64. Plus 36 is 100. Square root of 100 is 10. Okay, yeah. Well, you can say Pythagoras, yes, but we have the formula that the modulus of AB. Modulus of a vector is the square root of the squared coordinates. Now, I want to skip these. because equation of a straight line is not really related to our assignment. So, and I'm running out of, I don't have much time left, so I'll skip this bit. Problem 4, you have a plus b equal to a minus b. Show that a is perpendicular to b. Well, there's two different ways of doing this. Okay, so would you still give the equation in the form y equals mx plus c? Yes, exactly. Could that question be done without vectors, treating everything as a coordinated and solving algebraically in the same process? Different mental angle, if that makes sense? Yeah, absolutely. You can use it algebraically. Could you give the answer in IJ notation? Yes, you can. I personally don't like IJ notation. It's difficult to read for me, but it's up to you. Yeah, I mean, you can use it. So Nam, yes, you can do that, as you're saying. Okay, so we have a plus b and a minus b. So let's square them. So let's find a plus b squared. There is a vector. So a plus b is a vector squared. And we could say that is a plus b multiplied by a plus b. And this can be written as a squared plus 2ab plus b squared. I'm not using vector symbols here because I already know that modulus that a squared is equal to modulus of a squared, which is equal to a squared. And we take this vector a minus b squared is equal to a minus b that's equal to a squared minus 2ab plus b squared. And they're equal to each other. Yeah, because the moduli a plus b modulus squared, a minus b modulus squared is that. And because of that, we have a squared plus 2ab plus b squared equal to a squared plus minus 2ab plus b squared. A cancels, b cancels, and we have 4ab equals 0. And AB is 0. And that means that A is perpendicular to B. If A was a vector before you squared it, would A squared is a number. So A is a vector and A squared is a scalar. That's important to understand. Yes, if the scalar product of two vectors is 0, because the scalar product B is equal to modulus of A, modulus of B, cos theta. If this is equal to 0, that means that cos theta is equal to 0. That means theta is equal to 90 degrees or 270 degrees. In both cases, A is perpendicular. A is perpendicular to B. A is perpendicular to B. Yeah, so we're given that A plus B is equal to A minus B by modulus. Show that the vectors are perpendicular. There's another approach to this question. I think so method 2. Let me show you. It's quite an ingenious way of doing it. So let's draw vector. If you have vector A and vector B, let's draw them. So let's say you have vector A and you have vector B. B. And if you draw the one side of the parallelogram, so this is vector A plus B. A plus B. Now, if you draw this vector is going to be A minus B. But this is a parallelogram, and A plus B and A minus B are diagonals of a parallelogram. And if the diagonals of a parallelogram are equal, that means it is a rectangle. If diagonals, if A plus B is equal to A minus B, then it is a rectangle. And therefore, A is perpendicular to B. Method 2. Method 1. It must be a rhombus. Well, yes, but also no, a rectangle. It doesn't have to be a rhombus because they're not perpendicular. Is a component. Yes, Anish, that is a valid method. Isn't that the same as problem 8 in the assignment? It might be. It might be. If it is, that would be disappointing for you. Oh, well, so very similar, not the same though. Okay. I imagine how disappointed you would be that I've accidentally solved a question for you and you don't get to do it. Anyways, problem 4. Problem 5, sorry. How much time do I have? Not too much. I think I'm going to skip problem 5. It's not really related to what we're doing. Problem 6, the values of alpha and beta such that this. This problem 6 is okay. I'll do problem 6. It's very straightforward. Problem 6 is super easy. So modulus of b is 3. So that means modulus of b is 3. Therefore, 2 squared plus beta squared plus 1 squared is 9. So beta squared is 9 minus 5 is 4. So beta is equal to plus or minus 2. Then A is perpendicular to B. A is perpendicular to B. And that means that the dot product is 0. That means that A dot B is 0. Therefore, A is, so 3 minus 1 alpha multiplied by 2 beta 1 is equal to 6 minus beta plus alpha is equal to 0. Now, if beta is plus 2, alpha is beta minus 6. So answer, so alpha equals minus 4, beta is equal to 2, or alpha is equal to minus 8, beta is equal to minus 2. The 9, yes, the 9 came from because it's 3. So it comes from the formula. Sorry, I might. So modulus of B is equal to the square root of 2 squared plus beta squared plus 1 squared. And we know that modulus B is 3. So it's 3 squared is equal to 2 squared plus beta squared plus 1 squared. I hope that makes sense. Io, does that make sense? Okay. All right, so yes, that is the answer. So quite pretty straightforward. Okay. So a trolley moves 70 meters along the track. So you can assume that this is a thrust force, it's a pulling force. Let's call it F1. Let's call this is the weight of the trolley. This is the normal reaction of the trolley. And this is F2, the friction force. Okay. So the displacement is this. The displacement is in this direction. Displacement S. And it's 30 meters. 30 meters. So let's calculate the work done by each force. So work done by each force. So work done by force 1 is equal to the force multiplied by the force oh, 70 meters. Sorry. What's going on? Not sure. Okay, the force is force multiplied by the displacement, because we know that the work is force multiplied by displacement. There's force multiplied by displacement multiplied by cosine of the angle. So for this force, this 200 multiplied by 70 multiplied by cosine of 0 degrees, because the angle is 0, because the force is in the same direction as the displacement. So that is 200 times 70, 1,000, 14,000 joules. Work done by the force 2 is force 2 multiplied by the displacement multiplied by the cosine of the angle between them. And this is going to be 150 multiplied by 70 multiplied by cosine 180. Yeah, very important. Cosine 180. Does that make sense? Because it's in the opposite direction. So the angle is 180. So 150 times 70. So 10,500. So minus 10,500 joules. Now the work done by the weight. Work done by the weight is the weight multiplied by the displacement multiplied by cosine of the angle between them, and cosine between the weight and the displacement is 90 degrees. So that's going to be 300 multiplied by 70 multiplied by cosine of 90, which gives you 0 joules of work. And the work done by the normal reaction force is the normal reaction force multiplied by S multiplied by cosine of 90 degrees again. So that's 0 joules again. Can you say the displacement is minus 70? You can say the displacement is minus 70 in the positive x direction. When you say that phrase, in the positive x direction, you are saying the projection of the displacement on the x-axis. So if the x-axis is in this direction, the projection of S onto the x-axis is going to be minus 70. So that's what we mean when we say minus 70. In our case, the displacement is, okay. I'll show you one more thing for this question, because I think this is important to understand. So let's find total work. Total work is obviously 3,500. So it's 14,000 plus minus 10,500 plus 0 plus 0, which is 3,500 joules. You could also do it by finding the resultant force and multiplying with the displacement. That would be the same value. Total work is that. And there's something that is called the work energy principle, which says that the change in kinetic energy is equal to the work done. That means that if the trolley started from rest, the kinetic energy is 3,500 joules. And you can work out the speed because you can work out the mass. What is the mass of the trolley? You can use 10 for G. Mass of the trolley is 30 kilograms. Yes, therefore 1/2 mv squared is 3,500. So you can work out V, which is equal to 7,000 7,000 divided by 30. So V is approximately square root of 700 divided by 3, which is 700 divided by 3, 15.3 meters per second. 15.3 meters per second. Yes, thank you. Thank you, Archie. Yeah, so you can work out the speed. And this is an important thing. So the work done on an object is equal to the change in kinetic energy of the object. That is a fundamental principle. It's so important. The change in kinetic energy is the work done. I can't stress that how important it is. However, let's call this method 1. Method 1. Method 1. Using absolute values of vectors. Using modulus. Moduli. Method 2 involves using column vectors. Method 2 using column vectors. And this is slightly less physical, more mathematical, but it's another way of that is a good question. Karim and Jonathan, you're both asking the same question, but Karim is asking in a direct message. So wasted heat. What do we do with wasted heat? Well, wasted heat is actually present here. This is the wasted heat, because that's the work done by friction. This is the wasted heat, which is the work done by friction. This is the point where you say, whoa. Okay, so it's not 100% efficient. It is what, 25% efficient, is it? Yeah, I did. Okay, so yeah, I mean, you don't have to consider, like, we have considered wasted heat. And if the friction, imagine the friction is 200, that means you're moving with constant speed, and the work done would be 0, and the change in kinetic energy would be 0, because it's moving with constant speed. Kinetic energy is not changing. And the work done by the forward force is plus the work done by the backwards force is 0, because they are in opposite directions. Then the work done is 0, and the change in kinetic energy is also 0. No, the speed is not 0. Okay, I have to demonstrate that. So fetch. So we have a box. Okay. I'm pushing the box with a force of 94 newtons, and the friction force is 94 newtons. The total force is 0. I hope you believe me. The sum of forces is 0. The speed is constant. The work done by the applied force is equal to the work done by the friction force. Well, with a minus. So here, so the work done by the applied force plus the work done by friction is 0. So the change in kinetic energy is 0. So what's the speed? 0. Wait, sir, but if you think about if you're pushing a trolley and it's going at constant speed, you're not doing 0 work, are you? No, you're not doing 0 work. You're doing work. And obviously, the more friction, you're doing work against the force of friction. If there was no friction, you would be doing no work. You would, because the force would be 0. Ooh, I'm not sure what that means. You're doing work because you're pushing and it's moving, right? So full stop, you're doing work. But then the speed is determined by the difference in force when the force were unequal. Yes, but that's not the point. The point is the box has kinetic energy. We don't know how it came to have kinetic energy. Someone pushed it, or somebody shot something at it, or kicked it with a bat. We don't know. We're not interested. We're only interested in what's going on right now at this moment. If the forces were equal, it would be 0 meters a second. Well, of course, yeah. It takes some time to accelerate. Changing this force balance. So the acceleration is 0, and the speed is constant. So Julian Tobacco, this acceleration is 0. That's important. I was interested in how it gained the energy for the speed. Well, we don't care. I mean, of course, I pushed it. Yes. So yes, I push it and it accelerates. I have to push it more than the friction force. And then I reduce the force to 94 because that's the friction force. And yeah, that's how I do it. But that's yeah. If you have no friction, this is a box without friction. So look, I start pushing, it starts accelerating. And then I stop pushing. So I'm not pushing. I'm not doing any work. There's no friction, so friction is not doing any work. So the total work is 0. The total change in kinetic energy is also 0. Work done. Work done. 0. Change in kinetic energy is also 0. Okay. The second method I wanted to use is I wanted to write them all as column vectors. So I'm going to write the displacement. The displacement vector is 70, 0. Because it's 70 to the right, 0 up or down. F1, the first force, is 200 to the right and 0 down. F2, the friction force, is minus 150, 0. F2. The weight force is 0 minus 300. And the normal reaction force is 300. No. 0, 300. Okay, are we all happy with that? Are we all happy with the forces? I'm just gonna keep forgetting the shortcut. I have a new computer, and there's a different shortcut for the snipping tool. It's annoying. I've been using the same shortcut for 2 years, and now. Yes, so you have this. So n is 0, 300. This is 0, 0 minus 300. This is 200, 0. This is minus 150, 0. And let's multiply. So the work done by the force 1, is F1 multiplied by S, which is 200, 0, multiplied by 70, 0, which is 14,000 joules. Because 14,000 plus 0 times 0. So it's 200 times 70. Yes, I hope you know the formula. 200 times 70 plus 0 times 0. So 14,000 plus 0, and that gives you 14,000 joules. The work done by the second force, so F2 multiplied by S, is equal to minus 150, 0, 70, 0. And that gives us minus 150 times 70 plus 0 times 0, which gives us minus 10,500 joules. The work done by the weight force is 0 minus 300 multiplied, it's a dot product, 70, 0. And it's 0 times 70 plus minus 300 times 0, which is 0 joules. So the work done is 0. And the work done by the normal reaction force is 0, 300 multiplied by 70, 0, which is 0 times 70 plus 300 times 0, which is 0 joules. So the same result using column vectors. So you can see how useful vectors are after all. Yeah, I mean, it's super useful. Hossam, yes, of course. You can do 200 minus 150 times 70 by all means. But I'm not showing you a method of doing a problem, right? If you had this problem, that's not what you would do. You would do that, what you're saying. You would find the resultant force and multiply it by the displacement. But I'm showing you the underlying physics of what's going on, and whichever way you write vectors, it will give you the same result. It has to. There are different approaches, and it's such a huge thing. I mean, I hope you found this useful and inspiring, hopefully. So yeah, I'll stop here. I wanted to do a very similar question here, but with an angle. Makes it slightly more interesting. So you have an angle theta here. Well, let's say theta is 30 degrees, for instance. And you have a pushing force, you have a normal reaction force, you have a gravity force, and you're pushing it at constant speed. The box goes up to here. And let's say the distance is 20 meters. And you find the work done by each of the forces. Okay. When you have an angle, do you just project forces on the slope? Yes. Yeah. You can do that. Or you can find the displacement vector. The displacement vector in this case is going to be 20 cos theta, 20 sine theta. Then you can say that the force F, this F1 is whatever that is. Then the weight force, that's simple. That's 0 minus W. And this is, well, this is the normal reaction force. You will need to separate that into components as well. A different way of doing it, but you can use Fs cos 30 as well. Okay, brilliant. So I hope that helps. I might do this question. Next week. We have 2 weeks. Well, a week and a half. You have a week and a half before the deadline. So next week we will go through that. Right. Brilliant. Okay, see you then. Oh, Alex, you did the old one. Can you please adjust? It's not too much. It's not too much to change. Yes, but please change it. We will. Please change the solutions and the numbering of questions. They are slightly different. So please adjust. Is math harder than physics at A level, at undergraduate level? Maths. The maths at COMPOS, students find it easier. Students find maths easier than physics. So yeah, it's pretty approximately the same level as further maths. I'd say approximately the same level. Some of it is A level, some of it is further maths level. So some of it is just maths, some of it is further maths. And definitely not harder than undergrad. So we're sitting right between A level maths and undergrad. So we're somewhere in the middle. Okay, see you all. See you. Enjoy.